With this lecture, we cover the basic laws used in electrical and computer engineering that are applied to circuits to find the currents and voltage flowing through different components. The first law that we will cover is Ohm's law. The objective of this lecture is to explain the relationship between resistance, current, and voltage, known as Ohm's law, which is covered in Chapter 3.1. I will give a couple of examples and then discuss how Ohm's law can be applied to a short circuit and open circuit. Ohm's law relates the electromotive force, or voltage, V, to the amount of current that can flow through a resistor, R. V equals IR. This is a linear relationship, obviously, so a resistor is considered to be a linear component. If we look at the units, volts is equal to amps times ohm, where an amp is equal to a coulomb divided by seconds. These relationships allow you to cancel units in more complicated problems. In this example, I will apply Ohm's law to determine the current that's flowing through a resistor. In this example, 2 volts, being supplied by a DC voltage source, is forcing a current to flow through a resistor. The resistor value is 1 kiloohm. Applying Ohm's law, V equals IR, or rearranging terms, I, current, is equal to V, voltage, divided by R, the resistance. Substituting in the numbers, we get that current is equal to 2 volts divided by 1 kiloohm. To continue this problem, what I have to do is take the prefix in front of the ohm, the K, and convert that back to a number. Since K is equivalent to 10 to the 3, 1 kiloohm is equal to 1,000 ohms. Therefore, I is equal to 2 volts divided by 1,000 ohms. Performing the math, we get that the current is equal to 2 times 10 to the minus 3 amps. However, we can't stop here. I need to convert the 10 to the minus 3 to the appropriate prefix. Therefore, the final answer should be 2 milliamps. Note that I have not used the trailing zeros. You do not need to write 2.00 milliamps. 2 milliamps is sufficient. Suppose the 2 kiloohm resistor in example 1 was replaced with a 5 kiloohm resistor. We would expect that the current would decrease because there is an inverse relationship between current and resistance if the voltage is held constant. To calculate the new current that would flow, we again apply Ohm's law. I equals V divided by R. As expected, the current decreases to 0.4 milliamps. Suppose we have that 5 kiloohm resistor, yet we want the same amount of current flowing through that 5 kiloohm resistor as we had originally calculated for the 1 kiloohm resistor, that being 2 milliamps. We now need to find out what magnitude the voltage needs to be in order to drive that much current through the 5 kiloohm resistor. Using Ohm's law, V equals IR, we find that the voltage required is 10 volts. This increase in voltage is expected because there is a linear relationship between resistance and voltage when current is held constant. Alternatively, what we can say is that to obtain the same amount of current through a larger resistance component, a larger electromotive force, voltage, needs to be applied to the component. If we flow current through a perfect conductor, or a short circuit, which has 0 resistance, then using Ohm's law we know that I times R will have to be equal to 0 volts, or 0 volts is generated across the resistor as we force current through it. Thus, no matter how much current flows through a perfect conductor or a short circuit, there is no voltage drop across the short circuit. Alternatively, what we can say is that no force is required to allow current to flow through a short circuit. If instead we try to force current to flow through a resistor that has infinite amount of resistance associated with it, we call this type of resistor an open circuit. If we analyze Ohm's law To try to determine how much current will flow through an infinite ohm resistor, we find that that current will have to be equal to 0 amps as long as we're not talking about an infinite amount of voltage being applied to force the current through the resistor. Ohm's law is the relationship between the electromotive force, voltage, that's required to have a specific current flow through a resistor, V equals IR. This is a very important relationship that must be learned for this course. We also discussed two particular examples of the extremes in resistance. Short circuit, which is a component that has zero resistance to it, and therefore no voltage is needed to allow current to flow through it. And an open circuit, which has infinite resistance, and therefore no current flows across an open circuit no matter how large the voltage applied to that particular component is.